begin. I'm slow. We're doing today to our next major larger topic. Say that is economic growth. It's theory of economic growth. It's chapter 17. Hopefully we can finish off this today and on Wednesday. So economic growth is related indirectly to what we have been doing thus far, which is primarily a theory of business cycle and theory about what the governments can or cannot do in order to prevent or avert this business cycle. The whole discussion of fiscal policy, monetary policy, the causes of recession, the different techniques of trying to minimize the recession to stimulate the economy. Economic growth as a problem, as a concept, is more of a long-term phenomenon. So there are two types of changes that macroeconomic theory studies. One is the short-term business fluctuation, that would be the business cycle. The other one would be the long-term trends, that's the theory of economic growth. So we're going to be doing this second this week. Just go over some of the basics, bare bones, theory and modeling of economic growth. I will remind you of something that I might have mentioned once or twice at the very beginning, when I was introducing the very subject of macroeconomics. I drew a graph. I remember it. I drew many graphs, but this one is one among the first ones. You have a time on the horizontal axis, and you have real GDP on the vertical axis. And as we can draw essentially two different graphs describing the relationship between the passage of time and the increase in GDP, increase in income, increase in wealth, however you want to define it. You can draw a curve like this. This would be, let's say, beginning 1700, and this would be 2021. That's the time axis of coordinating system. You can draw a curve like this. That's a growth curve that shows the relationship between the passage of time and the GDP. Or you can draw a curve that will look something like this. This is also a growth curve. Now you can guess that the straight line, that the linear function here would be a long-term economic growth. This one is long-term. And you guess this jiggly one would be a short-term curve. When you look at the economic growth in the United States over a period of 100 years, for example, since the Civil War, you get the growth rates of GDP per year, every single year, you add them up, all, whatever they are, and divide them by the number of years. And you get an average growth rate over that time period. Let's say that's like 3% long-term growth rate. And then you just plot the years against the real GDP, and you connect the dots, and you get a linear curve. Or you plot this relationship. This, and then you add 3% higher, 3% higher, 3% higher, 3% higher. It's a nice linear curve. But now we know in reality, when you zoom in into the curve, when you increase the resolution, so to speak, on 5 years, 6 years, 10 years, you see that this increase is not even. It's not 3% every year, it's 5% in some years, it's minus 1% in some years, there are recessions and so on. So this curve that looks like it's fluctuating around the trend line, around the trend curve, is the curve pertaining to the short-term business fluctuation. So those dips below the trend line were recessions. That's what we studied as well. See those downward trajectories here, repeated recessions that we spent so much time trying to understand and analyze and see whether governments can do something to prevent it, moderate, and get them out of them, and so on. So that's this jiggling curve is the subject matter on the theory of business cycle. The long-term curve is the theory of economic growth. So economic growth as a theoretical concept pertains to the long-term trends. The main one simplifying element of the analysis, one fortunate circumstance here is that the entire analysis of economic growth, at least the one that we will do in this introductory class, will be based on just one simple concept. The variations and different interpretations of just one basic concept, and that concept is a production function. So what happens to the production function? The movement along the given production function curve, shifts of the production curve. You will see how the analysis works in detail in 10 or 15 minutes, but that's the only key analytical concept of the whole analysis of economic growth. Before that, we have to define economic growth. So one of the things that both the short-term and long-term analysis have in common is that they're measured in the same units. Both short-term fluctuations and long-term trends are measured in the units that are rate of change, percentage change in GDP. Delta Y, or delta real GDP. So you know that delta in mathematics is always simple. The difference between the subsequent conditions and initial conditions. Delta x is always x2 minus x1, with x1 being the initial condition. So what is the delta real GDP? It's a percentage increase in real GDP year to year. That's called sometimes absolute rate of GDP change. GDP was $100, now it's 103. That's 3% increase. That's the unit in which we measure both short-term fluctuations, recessions and expansions, as well as long-term trends. Say, what is a recession? It's 2 consecutive quarters of negative real GDP growth. We use the same metrics to define a recession, to define when an economy is in a short-term disequilibrium or a recession or one, as well as to talk about which factors contribute to the long-term economic growth. We measure long-term and short-term disequilibrium. Okay, in addition to absolute rate of real GDP growth, you can have a per capita growth. So that means you have percentage increase divided by population. So you can use this to adjust for the population changes. So you can have 5% increase in real GDP and you have 1% increase in population. You have to adjust for this effect because you are now dividing 5% more income on 1% more people. So the real growth would be 5%, 4%. So that's per capita. GDP growth is how much a single person, the income of an average person increases per year, so the period of time. Now, Another note of caution here, that here we enter the area of big numbers. That the superficial impressions that we might have when we look at the economy from a short-term perspective may deceive us in predictions and estimates that we may make about the long-term trends. For example, if I told you that American economy increased 3%, that this is the long-term trend, from 1900 or 1885 until 2020. But if I told you that it increased only by 2% on average every year since 2005, we say, okay, that's not a big deal. It's just 1 percentage point less. It's not such a big problem. And I'll tell you why you might be wrong. If America grew from after the Civil War in the late 19th century until today at 2% average growth every year on average instead of 3%, you know how large American real GDP per capita would be? Which country would be closest to America? Which country America would be closest or relatively close? Just 1 percentage point a year less. Mexico. America would have been like Mexico. So see, what might not look as a big deal 1, 2, or 5 years, it's a huge, gigantic deal over a very long period of time, 100 years, 150 years. So we have even a mathematical formula that very nicely captures this fact. And mathematical formula pertains to one statistical test that we can make about how fast an economy is growing. This is expressed in the number of years that need to pass with the existing average growth rate for an economy to double, real GDP per capita to double. This is known as the rule of 70. So the number of years to double. If you want to calculate it, how many years have passed? You divide the number 70, don't ask me why 70, with an average growth rate. Number of years that need to pass until the real GDP doubles is calculated as 70 over the average growth rate that the country will have in the future. So let's assume that the growth rate is whatever, 5%. Then you will double your economies in 70 over 5, that will be 14 years. If you grow by 5% annually on average, you will need 14 years to double. If you grow by 2%, you will need 35 years. So now extend this to 140 years. You will see the difference. At the beginning of the second World War, or no, not at the end, the beginning of this peacetime period, especially 1950s, 1960s, the gap from that period of time until 2020, the gap between the European Union and the United States increased by something like 3%, even more. American GDP increased dramatically more. Why? Because the average growth rate in Europe was about 2%. In America, about 3%. So if we keep going along this path that we are on from early 2000s, we are entering this area of growth that the European Union has had. Very long period. That's a kind of relatively stagnant economy. So there's one exhibit one in the PowerPoint presentations that lists the growth rates of the American economy last like 10 years between 2005 and 2016, 2006. There's it's 2.7, then 1.8, then minus 0.3 2008, then almost minus 3 2009 recession, and then look at this 2010, 2016, all positive growth rates, but 2.5, 1.6, 2.2, 1.7, 2.4, 2.6, 1.6, on average 2%. Below the trend, below the long-term trend, 3%. So it's very important. The short-term fluctuations are not so important. Recessions from a standpoint of long-term prospects of an economy, recessions are relatively unimportant. They come and go, but what counts is the long term. It's better for you to have 9 years during which you grow by 6% and then you have one recession, than not to have a recession and grow at an average rate of 1 or 2%. You will reduce by recession your average growth rate from 6 to 5 or 5.5%, and your average out everything. But you will not increase your average above 2% because you didn't have a recession. So there is no correlation between cyclical stability of the economy, the absence of business cycle, the absence of recession, and long-term growth. Most countries that are stagnant, that are lagging behind, that fail to grow because they cannot generate healthy expansions, not because they have frequent and sharp recessions. So that's another big variable. Okay, any questions as well? Okay, so this was easy. Just introductory stuff. Now on to production function. Let's first define a function. Mathematical function is a type of relationship between two variables in which we use one of them to explain the other one. That's one definition. So what is the variable that you use to explain something else? It's called mathematics. Y. No, there's a y and x. Okay. Y. This is called independent variable. That's the you use forever. High income is a function of height. To discover that tall people have higher income than short people. Nobody knows why. Nobody knows whether there was a causal relationship or it's just a statistical relationship. There is a very good correlation between the number of Republican senators and the number of sunspots. So you can plot that as a mathematical function without claiming any causal inference, right? Without claiming that really the Republican senators control the sunspots. So this is independent. Independent variable is whatever you use to explain something else, and dependent variable is the thing that is functionally related to the dependent variable that you want to explain. So that's the basics about mathematical function, and we usually describe it in this way that we plot dependent variable here and independent variable here. You remember that supply and demand could be defined as mathematical functions. So demand function is an inverse downward sloping function in which, as the quantity of good at your disposal increases, the price that you pay for the one additional unit goes down. That's mathematical function. So production function is another one. You can use functional analysis to make sense of problem of long-term productivity. So now we disregard completely all of the stuff that we discussed thus far, money and government and bonds and fiscal policy and Keynes and Friedman and all that, forget about it. That's irrelevant now. Now, what is relevant are the real factors. And production function is the most important analytical tool to make sense of us. So what is this function? It plots together why here should not be understood only in the generic sense as a dependent variable, but as standing for yield or real GDP, quantity of goods. Why the vertical axis? On the horizontal axis, you typically have one of the factors of production. Anyone remembers what are factors of production? You know, list a few typical groups of factors. What is a factor of production in general? Producing good factor of production. Come on, it's easy.
You just make the demand for the product.
The demand for the product. Yeah. For which product? For the final consumer good or
Labor?
Yeah, labor. So what else? A factor is anything that you need to use in order to produce. So it could be labor. Let's describe L. Labor. Material. Okay. What else?
Capital.
Capital. What do you mean by capital? Money. Okay. So do you use money to make the Volkswagen Jetta? No, you need other stuff. You need money to buy labor, but you need money to buy other things that you do, like material, like machines, like buildings, like intermediate goods. All of those artificial instruments of production, non-labor instruments, are called K, or capital goods. Non-human resources that are necessary for production. Sometimes there is another, sometimes it's P or R, different letters like natural resources. But we're going to simplify that. We're going to say, let's assume that all of that is subsumed under capital goods, like artificial instruments of production. What else? This list is not self-evident. For different purposes, you can use different things. In this analysis of the production function, one more term is used, and that is certain coefficient that is added to the production function, technological efficiency. That means how good you are as an entrepreneur with using a given quantity of capital goods and labor. It's a technological coefficient. And this technological coefficient measures simply how the level of technological scientific knowledge and the improvement in the quality of that's better machines will give you a better coefficient T. More machines will give you higher coefficient K. 10 machines instead of 8 will increase the quantity of capital goods. So those two factors here are quantitative. The number of workers and the number of labor hours, the quantity of machines, tools, and other goods. Labor factor, one more clarification. The unit in which labor factor is usually expressed is not the number of workers, but the labor hours. And this makes sense since we know Americans work more than French, so then 10 Americans will probably work longer hours than 10 French. So then in order to eliminate the subjective factors like labor law legislation, it means we just talk about labor hours instead of number of workers. However, whatever the route by which you come to 1,000 labor hours, but whether by getting more people or by getting the existing people to work more, it doesn't matter. For us, it's a matter of analysis, the labor. Factor labor is measured in number of labor hours. So this production function is usually then written as y is a function of technological coefficient applied to labor and capital. That's the basic post-elementary function, sometimes called in economic theory the Cobb-Douglas production function. After two economists, Cobb and Douglas, who formulated it for the first time. Okay, so that's the production function. So what are independent variables here? Those three. What is dependent variable? Why? You want to explain how productivity changes as a function of a given change in any one of these three factors. Okay, now how the analysis is performed. This is one critical issue. The analysis is performed in the following way, that you assume that all factors are fixed. But one is variable. So what you do, you say, let's assume that technological coefficient is fixed, is constant. It doesn't have to be. You can keep constant whichever two you want. But let's say for a moment that we control technological coefficient and capital goods. So they're constant, unchanged. And then the question that you ask in this analysis is, what's going to happen to productivity if I increase the quantity of labor factor, the number of labor hours? So the factor L is variable. That's the analysis. Pioneered essentially by Philip Wicksteed, one late 19th century economist, and became very quickly universally accepted. So now, let's take a look at the curve. The curve is not so easy to mathematically represent. You're not going to write down the precise formula. It could be different. But the curve's production function typically looks something like this. Fine, but maybe a little bit more smoothly drawn than I can do. Something like this. That's our production function. This point here is important. Okay, what can you tell me about the nature of this factor, this function? Independent variable is labor, of course, the only variable factor. Dependent variable is productivity, its ability to measure. What is the nature of the relationship between these two variables? These two are fixed, technology and capital, for now. As quantity of labor increases, what happens to productivity? It plateaus. Eventually it plateaus, but first, here, from this point to this point, it increases. It increases exponentially. What does that mean? That means when you increase first 10 units of labor, you're going to get 57 units of output produced. and you go from 10 to 20, you're going to increase it by 125. You're increasing returns. So first part of it. One thing that is for certain is the proportional relationship. Proportional relationship. That means you increase the quantity of labor, production increases, period, in general. But this is just the beginning. The second aspect is here, that just by eyeballing the curve, you see that this is not a linear curve. It's not a constant return on labor. It's not that you increase labor by 1 unit, you increase production by 5, and then you increase by the second unit, you increase it by 10, and then third unit you go to 15, fourth unit to 20. It's not like that. It's rather strange. Up to this point that I designated with the number 1, here you have increasing returns. That means you add more labor, you increase yield more than proportion. And then after this inflection point here, you enter into the area of diminishing returns. Yes, diminishing return. That means you add 1 more unit of labor, you increase productivity but less than before. And then 1 more unit, even less than before, and so on down the line. So that's, then you have, until a certain point, you enter the diminishing. This is one of the crucial concepts during production. Sooner or later, every production function will enter the area of diminishing returns. And eventually it flatlines, goes to 0. Sometimes even below 0. It flatlines. So here, let's say this is the quantity of labor X. You want to increase it to Ly. Here, what is the gain? The gain is almost 0. That's what the production function looks like. It looks at the relationship between the variation in one arbitrarily chosen factor of production and total output, while keeping other factors constant. Now, one principle that you unfortunately don't have in your book, as far as I can tell, and that is crucially important to understand why is this, why this looks like that. Is the concept of the law of returns. That would be the equivalent, almost the equivalent of marginal utility analysis in pricing. That's the key. What is the law of returns? The law of returns says that for every combination of one variable factor and multiple fixed factors, there is one and only one optimal quantity of a variable factor that maximizes total output. So for every combination of one variable and multiple fixed factors, there is only one optimal quantity of a variable factor that will maximize total output, total production. Translated into an even simpler English, this means that you can increasing one factor while keeping other constant can get you only so far. Sooner or later, you're gonna hit the wall of trying to raise your productivity just by increasing the quantity of one of the factors. So one of my favorite examples that I actually stole from mathematics. So Peter Klein, if you're looking now. I'm using this example. So imagine that you have that you want to grow some corn in a flower pot. You plant a corn stalk in a flower pot, and you want to grow some corn for fun. What do you need? You need a plant. What are the factors of production that you need to produce some corn? You need a plant. You need a flower pot. You need some soil, some water to water it, maybe some fertilizer, maybe box music to let it plant grow better, but that's optional. And then you're happy your plant is growing very nicely, you have some corn, and then you say, oh gee, I would like if I had a little bit more corn, if I increased my yield here. But I'm not going to do, I'm going to just increase the quantity of fertilizer that I use. And just add a little bit of miracle growth in order to boost the plant. You add whatever, 50 grams of miracle growth, and the plant grows even bigger, and you get a little bit more crop. How far can you go this way? You increase it a little bit, and it's going to increase slightly, but you cannot grow to some gigantic quantity of corn out of one corn stalk. And moreover, everybody, whoever worked on a farm and knows anything about agriculture, you will realize that it's very easy to burn the plant if you overdo the fertilizer. My father did it 4 or 5 times. So it's diminishing returns eventually kick in here. You cannot increase indefinitely. You cannot increase indefinitely your production of anything, but just increasing one part of production. So there is one optimal quantity of fertilizer that will maximize your production of corn. At some point, after 3rd or 4th or 5th dose of miracle growth, you will hit the wall. You will not be able to produce any more corn. Moreover, you may even decrease if you persist in adding new doses. So this then holds as a universal principle for any economy, macroeconomy, individual economy, that there is only one optimal quantity, maximum quantity of any one variable factor. So in this particular case, everything else was a fixed structure. You didn't want to add a new corn stalk, a new flower pot, a new quantity of soil, new water, nothing, just fertilizer. And there are limits to how much you can do. Now, this is a strict theorem that holds universal, the law of returns. Imagine if it were not the case. Sometimes the easiest way to prove that something is absolutely true is to assume that the opposite is the case and then deduce logical consequences from that opposite statement and see that they imply nonsense. So in this particular case, what would be the logical consequences that we can deduce from the claim that you can indefinitely increase, or there is no upper limit to how much you can increase your corn production by adding miracle growth. Theoretically, you can produce the entire world supply of corn in one flower pot. If there was no upper limit, how much you can get out. Get all those wonderful subsidies. So what you need to do in order to, if you really want to increase indefinitely or without principal limits, your production of corn or your production of grain, you will have to add more of the complementary factors of production. So sooner or later, you will have to add more flower pots, more corn stalks, more soil, more water to grow more corn. So the same applies here. You cannot just increase the number of labor hours indefinitely and increase productivity of the economy indefinitely. Sooner or later, you're gonna reach this maximum point. The only way how you can continue growing in this particular case would be to increase the quantity of the complementary factors. So this increase in the quantity of complementary factors is shown as a shift of the production function upward. See, that at any quantity of labor down there, you could produce more output. But what needs to happen? Either K has to go up, more machines. People using more machines can produce more per unit of labor. We know that. people who work with better, with more machinery and equipment, or other things maybe who can produce more stuff. Or technological coefficient might go up. Better machines, better production processes, better recipes for production may increase productivity, even if you use the same quantity of capital goods and the same quantity of labor. So, K can be constant, but if technological coefficient goes up, then with the same quantity of labor, you should be able to produce more stuff. And vice versa. Even if technological coefficient is constant, if you increase the quantity of capital goods, the same amount of labor will give you more. You lead to this shift in production function. So the problem of economic growth in general is how to keep shifting production function upwards all the time. So poor economy or poorly performing economy, this would be a production function of whatever, hunter-gatherer society. Dark ages between 600 and 1000. And the only illiterate people in Europe were monks in Ireland. Nobody else. And the Slavic and Germanic savages were sitting amidst the ruins of Rome, having no clue about how those giants or superhuman beings were here before they built the aqueducts and other technology. The devastation, economic devastation like that. What's like this? If this is like industrial revolution, productive capacity of English economy in the 1800s. If you want to draw the production function of modern post-industrial economy, probably the ceiling would be quite enough. And the main reason for that, the main productive factor that makes the difference, okay, is knowledge. So technology shifts production possibilities frontier of a given country dramatically upwards. So you may have heard about the guy called Thomas Malthus in the early 19th century, the guy who predicted widespread famine as a consequence of the Industrial Revolution. Why widespread famine? Because the experience of every other economic episode in human history was that the population increases, the means of sustenance, the production of goods and services cannot keep pace with the rate of growth of population. Population increases exponentially and the productivity increases over slower and slower. Because after a while, we would not be able to feed the population. It's a modern fears of overpopulation stem from this Malthus statement, the neo-Malthusians, people who flee. What he failed to predict is actually that we will shift our production function dramatically because of the new technological inventions. That we will be figuring out on an ongoing basis all the time the way how to get more out of less. Now we're using 20 to 25% less arable land to produce food for our population now than we did 100 years ago. And we're feeding now 8 billion people instead of 1 billion, 1.5, 100 years ago. How was it possible? Because we figured out ways to get much more food out of the same acreage. Same natural resources, we get 10, 20, 30, 40 times more food per person. Technology, fertilizer, modern machines, genetical engineering, green revolution, all techniques that we use to increase the crop yields allow us to feed a much greater population than we could have done 100 or 200 years ago. So that's the challenge of economic growth, is how to what shifts the production possibilities curve, production function in a sustained, ongoing fashion over time. Just one more thing for this. Of course, we cannot do without our aggregate demand, aggregate supply, even if I promise that. Just one more thing, the relationship between production function and aggregate supply curve. Remember now for a moment all this stuff that I told you to forget about, fiscal monetary policy and so on. We said short-run aggregate supply is manipulable by policy. So you can shift it left or right with monetary and fiscal policy. But the long-run aggregate supply curve is immovable by policy. How much an economy can produce based on real factors. Remember this phrase that I repeated probably 4 or 5 times at least. You can move it right or left only based on real factors. This is what I meant, real factors. Quantity of capital, quantity of labor, technological sophistication of society. We will see on Wednesday there are still other things that are influential here. Institutions, entrepreneurship, some non-tangible stuff that also influences it. But you can shift a long-run curve to the right in 2 ways. You can go along the given production possibilities curve. You increase your yield, your production that way. Or you can be moving your production possibilities curve upward. You'll also get some increase in a shift of the long-run curve to the right. So a shift to the right of a long-run aggregate supply curve of an economy is the same thing as increasing productivity, which could mean movement from one point to another, from left to right along a given production possibility, production function, or it could mean a movement between curves. Of course, the latter one can be preferred. Okay, any final questions?
After me in a long time.
Is it windy for you?